going to talk about some energy flow. We talked about evidence for Pangea, and so now we're going to talk about energy flow. So let's take a look at the energy of the Earth. So Earth's energy comes from two different places. What's the first place, based on what you see right here? What's the first place here, Terry? Where does energy come from, based on this picture right here?
The sun.
The sun. How about this right here, Bryce? Where does energy come from? Inside where, Bryce? Inside where, Bryce?
Inside of the Earth.
Inside the Earth, and specifically in the core, the inner core, mantle. Those are all hot, right? Well, the mantle and the outer core are actually hot because the inner core is hot, right? And if you remember, we said that the inner core is almost as hot as the sun. So it's only like 1,000 degree difference between the inner core. The sun is like 10,000 degrees Fahrenheit, average temperature. The core is like 9,000 degrees Fahrenheit. So I don't think there's a whole lot of difference between 9,000 degrees and 10,000 degrees if you were to put your finger in it, right?
Finger gonna turn to skeleton.
Your finger's just gonna probably dry up and fall off. Go and turn into dust immediately. Okay, so let's look right here. So we've looked at energy. We've looked at how the energy from the sun impacts Earth. And so let's look at these pictures right here. And what three ways Earth's organisms use energy from the sun? What do the plants do? They use energy of the sun to do what? These plants right here, to what? Make their own food, right? Okay, how about this right here? We use the instruments to measure the sun, and then we use solar panels here to what? To use the sun again and convert it into energy that we can use for our hair dryer or television or a computer or whatever, right? Whatever you want to operate. Okay, so that's three good ways that we use energy from the sun. Okay, let's look right here. So let's look at Earth's internal energy. We've looked at the sun. Let's look at Earth's internal energy. So the energy needed to cause the changes seen in the section that we talked about earlier comes from beneath the surface of the Earth. So because we get energy from the sun, we also get it from inside the Earth. And the heat of the inner core, the outer core, and the mantle is linked to many large-scale Earth processes such as plate tectonics, geysers. What's a geyser? Who knows what a geyser is? Tell me what.
Like a little thing that
Tell me, Terry. What's a geyser say? What is a geyser?
A geyser is a volcano-like thing that sprays hot water.
Sprays hot water. What are you gonna say?
Oh,
Same thing. Geysers. Yes, geysers. Actually, it's liquid from inside the. Most of it's mineral water. If you've ever been around a geyser, they smell like rotten eggs mostly. Usually there's sulfur in those geysers, so it's going to kind of smell like rotten eggs around that area. Anyway, so the heat of the inner core, outer core now is linked to many large-scale Earth processes such as plate tectonics, geysers, and also volcanic eruptions. Now look right here. We discussed earlier, we said there were 4 layers of the Earth. Well, they've broken it down here a little bit more. There's the crust, there's the upper mantle, there's the mantle, there's the outer core, and there's the inner core, okay? And different scientists do that, and that's okay. Okay? and then above that, look what you got. You got the troposphere, you got the stratosphere. Right down here on the crust is the biosphere. That's where we hang out, right? That's where life is. Then you got the troposphere, that's up above. Then you got the stratosphere, mesosphere, thermosphere, and exosphere, right? And those aren't to scale. You know, they're different sizes for each layer. So let's look right here. So you know about convection, right? We talked about convection when we talked about certain kinds of energy already. And so convection in the Earth's mantle, it's the materials in the Earth's mantle are constantly in motion, right? They're never still. As you travel through the mantle, the temperature changes, and to distribute this heat evenly, here's the mantle in here, and then here's the outer core. So to distribute this heat evenly, there are convection currents that move between the warmer and cooler sections. And when you think of convection currents, think of hot air, cool air, because that's what it is, right? Okay, so these currents are able to travel through the semi-solid rock in the mantle. This is semi-solid rock. When I think of the mantle, I think of pudding, maybe with some chocolate chips in it or some bananas or something in it, because there's some semi-solid stuff. They're able to travel through semi-solid rock in the mantle, causing changes in the land above. Okay. Uh-oh. Okay, so when you think about, we've heard the term convection. Anybody got a convection oven at home? I've got a kind of a smaller version of a convection oven. I can put a meal in there and it'll heat it by convection. And when it does, I always hear there's air constantly moving around that food. You can hear the air, the fan blowing, hot air.
Kinda like an air fryer.
It's kind of like an air fryer, you're right. So you've heard the term convection before in referencing to a conventional oven, or a convection oven, I'm sorry. So convection refers to the warming of a substance caused by the circulation of different temperatures of air. You got these temperatures of air going all around the food, and that's what's heating the food up, cooking it. Okay, so in a convection oven, a fan helps circulate that warm and cool air so that the food inside heats evenly. Okay? Okay, here we go. Okay, so differences in air temperature. Let's look at this. Who's this guy right here?
Is that Paw Patrol?
You remember who that is?
Is that Paw Patrol?
Who?
Paw
I
Patrol?
can't even see him. Oh.
Look like Paw Patrol.
Sparky.
Who?
Sparky.
Off of Paw Patrol?
Sparky.
Oh.
You know about fire safety rules, right?
Is that a show?
Well, it's part of a program that firemen use to teach you safety rules when you're in a fire. So let's look right here. So the process of convection works because warm air and cool air behave differently. Okay, warm air rises. What does cool air do?
Low.
Sinks, right? Warm air rises, cool air sinks, and it's cyclical. It's cyclical. It's a cycle.
Hot air.
Warm air goes up, and then as it gets up here, it cools. And as it cools, it goes back down, and then it heats back up and it starts rising again. It's kind of a cycle. Okay, but let's look at Sparky here again and think back to your fire safety rules. You probably should have learned those like in third grade, second grade maybe.
Yeah.
If there's smoke in a room, why is it important that Sparky in this picture right here gets as low as possible to the floor?
Because the coolest air down there in
The coolest air, and that's where the oxygen's at, right? Okay, the cool air is at the floor, and the other air is dangerous to you, right? The warm air?
all the smoke.
You got it. Okay, so as air temperature changes, so does its density and its behavior. Look right here. Warm air rises, cool air sinks. Warm air rises, cool air sinks. You got the idea. So this same phenomenon happens with all gases
Why doesn't our move?
and liquids such as ocean water. And it also happens in the semi-solid mantle of Earth. Happens inside the Earth as well, okay? Warm air rises, then it cools down and it sinks, and then it goes through the cycle all over again. Okay, got the idea? Any questions about that so far? There's gonna be a question coming up here in just a second. Okay, so let's look right here. So convection in Earth's mantle. Remember, convection is hot air and cool air, right? They're cycling. Okay, so let's look at these arrows here. And you see it's a cycle of air. There's a cycle of air over here. Okay, they're just like up. Hot air goes up, and then cool air comes down. So because the outer core, and here's the outer core, here's the mantle, here's the outer core, and there's the inner core. Because the outer core of the Earth is so hot, the materials that is close to it, look here, this is going to heat up real quick when I get down here, right? The cool air. The cool air is going to heat up, and it's going to rise. Okay, so because the outer core of Earth is so hot, the material that is close to the point will warm up. As it warms, it becomes less dense, causing it to rise closer to the surface. Okay, so now you got convection in the Earth's mantle again. So as these substances get closer to the surface of Earth, look right up here, they cool down, right? Then what's gonna happen? The air's gonna sink, right? And that gets closer to here, and then what's gonna happen to this? It's gonna get hot, right? And rise. Got the idea? Okay, so here we go again. So this convection current continues. The process will continue repeatedly. It's going to just repeat over and over and over. It's been doing that for 4.5 billion years. Okay, hot, cold, hot, cold, hot, cold, hot, cold. Okay, to around the core. Okay. All right. So here's a question. Are you ready? This is slide 40. Everybody on slide 40? Michael Carnell, you ready to answer on slide 40? Okay, here we go. Which of the following statements best explains why you think plates move? Okay, I'm gonna give you some choices here. Is it because volcanoes flow over the land forcing them to move, or would it be because the heat in the mantle causes the plates to slide? What do you think?
If you get that wrong, I'm laughing.
Huh? C or D, mark your answer.
If they get it wrong, you gonna laugh out?
I may. C or D, mark your answer, can't choose A or B. Mark your answer. Okay. We ready? I'm gonna move on here. Here's number 8. Did I mention we're gonna get a grade for this today? Which statement is correct? Hot substances rise, cold substances rise. Mark your answer. A or B, mark your answer.
For number 8?
Mm-hmm. Yes. Number 8.
Oh, that's easy, then they get down.
A or B, mark your answer. Okay. Ready to move on? Okay, let's look right here. Materials in Earth's mantle move in a circular direction. Circular. Is that true or false? Think of convection. What does convection do? That's really what they're asking. Okay, so we're gonna stop right there. We're gonna stop right there. We'll talk about this tomorrow, okay, for you at home.